Dear students, continuing with our lecture series on medicinal chemistry, this is our 18th lecture on medicinal chemistry and the fourth lecture on antiviral agents. During the first three lectures on antiviral agents, we have discussed details about what are antiviral drugs and what are the common viruses which are very prominent in different types of viral diseases. And out of these, the most common one is HIV, human immunodeficiency virus, then herpes virus, then hepatitis, then respiratory syncytial virus, and influenza A and B. So, in the first two lectures, details about different types of antiviral agents. Then in the second lecture, we have discussed what are anti-HIV agents and how through different antiviral drugs we can control the replication cycle of these HIV viruses. And in the second lecture itself, we have discussed the different types of HIV protease inhibitors, whereas in the third lecture we have discussed about nucleoside based or nucleotide based reverse transcript inhibitors, which can inhibit the replication of different types of HIV viruses. And now in this fourth lecture, we will discuss about non-nucleoside reverse transcriptase inhibitors. So, out of these two, the dalvarine and ephedrines, they are the two most commonly used non-nucleoside reverse transcriptase inhibitors. And first we will discuss about synthesis of dalvarine, and its brand name is Rescriptor. This is again used as part of highly active antiretroviral therapy for treatment of HIV. That means it is given in combination with other antiviral agents. And this was approved by US FDA in 1997, and its efficacy is lower than that of ephedrines. Therefore, it is not recommended its use as part of initial therapy, but this is mainly used during the antiretroviral therapy in combination with other antiviral agents. The adverse effects of this drug, they can cause moderate to severe rashes in the body when we take these antiviral agents. And other adverse effects, they include fatigue, headache, and nausea, in addition to liver toxicity. Again, the mode of action is same as that of other nucleoside or nucleotide reverse transcriptase inhibitors. Only thing is that here the structure is different. As far as the chemical structure is concerned, chemical structure is non-nucleoside, but the mode of action is same as we have seen in the previous lecture, that they will inhibit the uh, working of reverse transcriptase enzyme. So they what they do is they directly combine to suppress the activity of archaeal DNA polymerase of RNA and DNA dependence with reverse transcriptase enzyme. So when the activity of this DNA polymerase of RNA and DNA is inhibited by this reverse transcriptase enzyme, because of these types of inhibitors, then the cycle, the replication cycle is stopped, thereby the replication of the virus is not taking place. And then as far as synthesis of this uh, antiviral drug is concerned, the starting material for the synthesis, they are piperazine and 2-chloro-nitropyridine. Uh, when both of these they are reacted in presence of acetonitrile and BOC. Basically, BOC is used for protection of this secondary amino group in one of the nitrogen, so that other nitrogen that can undergo nucleophilic substitution of this halogen at the aromatic ring, and we will get this type of product. Then reduction of this nitro group take place in presence of hydrogen on palladium and charcoal. Uh, this nitro is converted into amino group. Then this amino group reacts with acetone and followed by reduction with sodium cyanoborohydride. This primary amine is converted into a secondary amino. And then this protection group is removed when this is reacted with trifluoroacetic acid or HBr in acetic acid. Then hydrolysis of this BOC will take place, and the deprotection of this nitrogen will take place, and this will again become a secondary amine. Then this pyridyl piperazine derivative then reacts with 6-nitro-indole 2-carboxylic acid. Basically the reaction will take place between this carboxylic acid and this secondary amino. So we know that amines on reaction with carboxylic acid, they will form a amide bond. So this type of amide is formed, and this amide, when this is reacted with hydrogen on palladium and charcoal in presence of DMF as solvent, then this nitro group is reduced to amino, and this amino group on reaction with methane sulfonaldehyde and pyridine will generate this sulfonamide group. So this is how dalveredine mesylate that is formed. This mesylate is formed when we are having a combination of methane sulfonaldehyde and pyridine and methane sulfonic acid. So this dalveredine mesylate act as an antiviral agent which is non-nucleosidic in nature, but its mode of action is again reverse transcriptase inhibitor. Then another method for the synthesis of this dalveredine mesylate is we can start with the ester of this acid which we have used in the first method. So ethyl ester of this indole carboxylic acid is used as the starting material. When this is reacted with hydrogen on palladium and charcoal, we know the nitro group will be reduced to amino group, and then this amino group on reaction with methane sulfonyl chloride, we know this amino will be converted into sulfonamide, and this uh, sulfonamide ester on reaction with strong base like sodium hydroxide, hydrolysis of this ester will take place, and the carboxylic acid will be generated back. And then this carboxylic acid will react with one of the amino groups of piperazine, and we will get the corresponding amide formed. Then this amide will react with 2-chloro-3-nitropyridine, and the corresponding here substitution of Cl by this nitrogen will take place, and we will get this type of intermediate. And then this intermediate on reduction with hydrogen on palladium charcoal, this nitro group will be reduced to amino group, and then this will react with the acetone sodium cyanoborohydride. Same way, this isopropylamine group will be formed over here. And then in the second step, this will react with methane sulfonic acid, and mesylate of dalpyridine will be formed. So basically, both the methods, they are similar. uh, in one method we are starting with these, whereas in the other method we are starting with this indole carboxylic acid as a derivative of carboxylic acid, as ester is used as the starting material. But in general, there is a similarity of use of different types of chemicals and reagents in the in both the methods. Only difference is that the steps which are taken, they are uh, in a different sequence in both the methods. Then afavirinase, brand name is Susteva. This is again a antiretroviral medication which is used to treat and prevent HIV and AIDS. Again, it has a similar chemical structure because this is again a non-nucleoside reverse transcriptase inhibitor. And mechanism of action again is same as we have seen in the previous cases. It inhibits the functioning of reverse transcriptase enzyme. And this is also recommended as antiretroviral medication, that is in combination with other antiviral agents. This is used to prevent a needle stick injury or other potential exposure to HIV disease. And the common side effects are similar to other nucleosidic or nucleotidic reverse transcript inhibitors: rashes, nausea, headache, feeling tired, trouble sleeping. Then here in this case, some of the rashes, they may be serious, such as Steven Johnson syndrome. Then other serious side effects, they are depression, thought of suicide, liver problems, seizures. And also this is not a safe antiviral drug during the pregnancy. It was used for medical use in the US in 1998, and this is in the list of essential medicine of WHO. Mechanism of action, as I already told you, is similar to what other nucleosidic or nucleotidic reverse transcript inhibitors they use. They inhibit the functioning of reverse transcriptase enzyme, so thereby viral RNA is not converted into DNA. So this is similar to what we have seen in the other cases. As far as method for the synthesis of alpha-glutinase is concerned, we start with 4-chloroaniline, and when this is reacted in the first step by this carboxylic acid derivative, acid chloride, then we know amide will be formed. So then this amide, when reacted with the strong base like n-butyl lithium, uh, the electrophilic aromatic substitution at this place will take place. This will act as an electrophile, and we will get trifluoroketone derivative is formed, and then reduction of this ketonic group in presence of HCl and acetic acid, followed by hydrolysis of this amide to amine will take place, and in presence of aqueous sodium acetate, this is again protection of this ketone is generated back to give us ketone. So alpha amino ketone is formed. Then this reacts with the 4-methoxybenzyl alcohol. Basically, this OH from here, H from here. So water is removed, we will get this type of secondary amine para-methoxybenzyl ketoaniline is formed. So this whole process gives us one of the starting materials for the synthesis of ephedrines. So this is the first one, para-methoxybenzyl ketoaniline is synthesized for the synthesis of ephedrines. Then second substrate which is required for the synthesis of ephedrines is N-pyrrolidinyl norepinephrine. So this is synthesized from this type of amino alcohol. When this is reacted with this dichlorobutane, we will get this type of N-pyrrolidinyl norepinephrine, which is optically active 1R2S. N-propyladinyl norepinephrine is formed as the product. So this is our second starting material. Then third starting material required for the synthesis of this antiviral drug is cyclopropyl acetylene. So when this acetylene derivative 2-chloro, sorry, 1, 2, 3, 4, 4-chloro acetylene is reacted with the butyl lithium in THF. So this proton is an acidic proton. This will attract electron density towards itself, thereby this carbon will become electrophilic carbon, and then the cyclization through removal of this halogen will take place to generate the cyclopropyl acetylene as the product. So this is how all the three reactants which are required for the synthesis of ephedrines, they are prepared. Then in the first step, the N-pyrrolidinyl norepinephrine and cyclopropyl acetylene, they are reacted in presence of 2-butyl lithium in THF at a very low temperature of the order of -10 to 0 degrees centigrade. And these two, when they react with each other in the presence of a strong base, then such type of chiral complex is formed. And this chiral complex, when this is reacted with para-methoxybenzyl ketoaniline, which was synthesized in the first step, then followed by when this is reacted with this para-methoxybenzyl ketoaniline at -50 degrees centigrade in presence of citric acid, then this type of propyl alcohol derivative is formed. When this alcohol is reacted with COCl2, then basically what will happen, the first chain, one H from here, one H from here, and both the halogen groups, one Cl will go with this H and one Cl will go with this H, and CO will get attached to oxygen and nitrogen. So cyclization of this amino alcohol group will take place, and we will get this type of oxidative cyclization product. And then this on oxidation with ceric ammonium nitrate in ethyl acetate and water lead to the formation of this optically active antiviral drug, which is called as efavirenz. So here basically what happens is ceric ammonium nitrate, what this will do is the hydrolysis of this part of the molecule. Basically this nitrogen carbon bond will break, and we will get our. These are the references which have been used in preparing this lecture. Thank you very much.